Hello guys, welcome to my Python YouTube channel, DESI ASTRO. So, in this tutorial, I am going to do some Python stuff related to observational astronomy. So, feeds file used in astronomical observation uh, through telescope. So, data cube. So, data cube, you can imagine it's like your Rubik's cube, similar to that. You can see that like it has six faces, and like it has like two-dimensional faces, and like na and it has a depth. So similarly, a data cube is like used to store a spectral data of a sky or a galaxy at different positions. So suppose a galaxy is your like say has a spiral galaxy. So data cube stores its spectral data at each position and on a particular wavelength. So you can understand basically from here. See, you can see that here's a data cube, your position x and your y position, and so xy position is for your like your whole galaxy, and the third axis is your like wavelength range. Like at each wavelength, say lambda 1, lambda 2, your galaxy has a spectra or an image. You can understand by more this picture. You can see that this data cube is like your all spectra has been stored one by one, just like a loaf of bread. So you can see that like here each bread piece is like two-dimensional, and it has been stacked to form a 3D cube. So in the same way, your galaxy spectra has been put together at each wavelength to represent as a data cube. So similar things we are going to do using a data cube. So our job will be to read these data cubes using Python. So let's do it. Okay, so we got idea about the basic of data cubes and what it contains. So it contains the spectra of your like each portion of a galaxy in a whole wavelength range of the instrument or a telescope. So now our job is to read this data cube and plots using Astropy Python package. Okay, so now for reading this, we have a data cube file. So I have a data cube file. I can show you the file. So this is my manga line cube fits file, and so this file contains some information and we have to read it. It's a spectra, its image. So let's do it. Okay, so first we'll import some libraries, say Astropy, NumPy, etc. So import library. Okay, so import NumPy as np, and then import matplotlib.pyplot as plt, and from astropy.input-output import feeds. So for reading feeds file. Now, so this will take care of your array. This will like used for plotting, and this is used for reading its data cube. Now this much we have done. Now we want to read. So read data cube. Now for that, type command, say your data cube, or just type cube equal to feeds dot open and give here your file name. So I will look for my file name, just put type so manga. So here is my manga feeds file, you can see that. Now run it. Okay, so it has run successfully. It means that your feeds file has been imported from your directory. Now just type cube, see what it is printing. Okay, so it is like printing so many information. So just type here cube.info and it will get your information. So cube information and run it. Okay, so here you can give a summary of your cube file, what it contains. So it has like primary SDU, image SDU and bin table SDU. So this contains data, 2D data, 3D data, and like here are like image SDU. So GRIZ and GPSF. So PSF stands for point aspect function. So here you can see that your primary SDU, image SDU has 74 into 6732. So this is your your XY pixels number, and this is your your wavelength range. 6732 wavelengths are there. Okay, so now let's read it. So our flux is in first image SDU, so read it. Okay, so for that read first image HDU. So for that just type data, or maybe you can write here flux. So flux equal to give file and take 1 for flux, 1, and then give data. Now see what it's printing. File is not found. Okay, so I have given the cube. So you should give your cube, not cube, and then give flux, what is it returning. Okay, so you can see that here it's a 3D value. Without changing your board, it has some numbers hidden. Okay, so now read the header. So for that just go and type cube1 then dot header. Okay, so here you can see that it has some basic information about your evaluation. You can see that it's axis XYZ 74 into 6732. It has the author name sum, and it has your telescope SGSS 2.5 inch, manga instrument, and then it has some your exposure time then it has array date and plate ID, manga ID, your APRO is given here, some your coordinate conversion matrix is given. So these things have been given here. Okay, so what else you can get from here? So suppose you want to print some information, cube1 dot header, and you want to know what is the array. So just run it. Okay, so what is maybe you can type just copy it. Let's see what information you have. So you have it's object array, not array. Okay, so just type here object array and run it. So here you can see that your object array is 229.525 degree. So this way, like, you can get your any information from your header. You can also get like object deck. Okay, so these things you can also print. Okay, now come to the point. You have your like data cube. So suppose like I want to read the galaxy image of your whole galaxy. So give here galaxy image. Okay, so for that what I will do, I will extract the image of the galaxy from the data cube. So for doing that I need to slice it. Okay, so for that I will type say image and I will cut the data cube. So you can say flux image equal to say flux, and now your data is like 3D data cube, so like you have the 3 axes. So image, so you want your galaxy image at a particular wavelength. So how to give it? Say I give say 3000 angstrom, and then all two are like blank. Now just run it. So you go to image and then type plt.imso for 2D image and then give image here. Now run it. Okay, so here you can see that you got an image of your galaxy at a 3, just writing at 300 angstrom. Now you can also change the galaxy image. Let's go for your 5. See, your galaxy image is changing. Let's go for 900, 9000. Okay, so it's the outer point, so it can only take value up to 6732. So 6731. Okay, so nothing is there. Maybe you can go for 20. Okay, so here's a small image of your galaxy. You can see that. I mean, it is the image of a data cube at the particular slice or the loaf of bread. So it is your galaxy at a particular wavelength. So I'm just putting here 3000. Okay, so here is my image. And also, like, you can add here percentage matplotlib widget to like import some. Okay, so here you got some cursor. Just type here plt dot figure. Okay, so here you got some keys. Now you can zoom this image. Okay, so you can see that here, like, your pixel is visible, like this is your like 1 pixel, and your whole pixel is 74 into 74. Okay, so I hope you got the idea that how to read your image. So this is how image looks like at a say lambda particular wavelength. Now this much we did. Now come here and read spectra from data cube at given xy. Okay, so for that now read a spectra. So for that, again we need to slice the cube on like going from all into your wavelength range on a particular xy position. So suppose that I want to obtain a spectra. I want to open a spectra at say I want to open a spectra of the galaxy at 37 into 37 pixel or the pixel position. So for that, type here a spectra and then cube, and it's it's flux, and then you want to go into your all wavelength range. Okay, so go into all wavelength range, but you have to give your x and y position. So give 37, 37. So I'm committing it at 37, 37. What is happening here? Yeah. So plot a spectra at this location. So for that, just type command plt.plot and give your spectra. Now run it. Then type plt.show and give here plt dot figure. Now run it. Okay, see here you got a nice spectra, and you can see that this spectra is at location 37, 37 pixel. You can see that some lines are there. You can also change. Let's change it. What things we are getting. Okay. You go to 30, 30. See, your spectra is changing. You can go to 30, 37. You can go to 38. Sorry. 38, see here. You can see here emission lines are there. You can go here 37, then again 37.